Alright, just going to have a look at some non-calc exam questions for Unit 3 and 4 Year 12 Methods course. So the first question I'm going to look at is the continuous random variable x is defined by the probability density function f of x equals q on x between 1 and 3 and 0 elsewhere everywhere else. Now this is a q, hopefully it comes through clearly that it's a q, it is not a 9. Now we are asked to determine the exact value of q. Now in order to do that, we know that because this function, alright, it is a continuous random variable probability density function, so we then know that if I take the integral between 3 and 1 of q on x dx, I know that that area is going to be equal to 1. Now to determine the integral of q on x, it is just q ln of x, right, and then we are substituting in our 3 and 1, and again we know that is equal to 1. If I do substitute in those values, I end up getting q ln of 3, just like that, subtract q ln of 1 equal to 1. Now the natural log of 1 is equal to 0, so we can then simplify that down even more, and we can then get q natural log of 3 is just equal to 1 because that is all equal to 0. So therefore q is equal to 1 divided by the natural log of 3. And that is your final answer. The exact value of q, 1 divided by the natural log of 3. Now there is another part to that question, and I've got it just here. So the next part of that question says to determine the probability between 2 and 3 of our probability density function that we had earlier. So this one just here that we had earlier, we are, instead of between 1 and 3, we are now finding between 2 and 3. Now because we have our, I'm just going to rewrite this here, we have our f of x is equal to q on x and 0 between 1 and 3, and then 0 everywhere else. Because we have now determined that q is equal to 1 on the ln of 3, we can now update this. Alright, we can now say that 1 on the ln of 3 on x, alright, between 1 and 3. Alright, we can now say that, and then 0 elsewhere is my probability density function. Alright, so now that we want to determine the probability between 2 and 3, I take this one here, and I'm going to do the integral just like we did with our last question. The integral, instead of now between 1 and 3 though, we want it between 2 and 3. So I'm going to just do this over here and just zoom in a little bit. So with my one here, what I can actually do is now actually determine, just so we can still see that one there, I can now factor out this. Alright, 1 on the natural log of 3, that's just a variable, it's just a number. Okay, so we can actually factor that out of our integral when we create it. Now remember, my question was asking me between 3 and 2. Alright, so 3 and 2, just like that. Now because I've factored out this of my my usable f of x, that is just going to become 1 on x dx, just like that. Now the integral of 1 on x we know is the natural log of x, but I still need to incorporate my 1 on ln of 3, and then this is going to be between 3 and 2. Substituting in 3 and subtracting it from the substitution in of 2, get 1 on the ln of 3 multiplied by the ln of 3, subtract 1 on the natural log of 3 times by the natural log of 2. You notice I'm substituting ln of 3 and natural log of 3, or the ln of 2 and the natural log of 2, they still mean the same thing. Now to simplify this ln of 3, it's like saying the natural log of 3 divided by the natural log of 3, which is actually just going to give me 1. Alright, and then this part here, we just leave it as is. Remember, this is all non-calculator. Okay, all these questions non-calculator. Alright, and this is my final answer. Alright, so my original question was to determine the probability between 2 and 3. In our previous question we determined Q. We determined Q to be the 1 on the natural log of 3. I then was able to update my probability density function, alright, to be Q 1 on the natural log of 3 on x. Now because this is just a number, alright, when I've then gone to do my integral, I have been able to factor out that constant, alright, 1 on the natural log of 3, then determine the integral between 3 and 2 of 1 on x, and getting my final answer here. Now the next question we're going to have a look at is, given that f prime of x equals x squared multiplied by the natural log of 2x plus 1, determine the second derivative, or f double prime of x. Now I guess the most important thing here, it says don't simplify. Alright, so this is a product rule question because we have two different functions, alright, two separate things multiplied together, so we're going to use our product rule. Now remember, our product rule, we do f double prime of x equal to the derivative of our first part, so the derivative of x squared just becomes 2x, and then we multiply that by the original part, natural log of 2x plus 1. I then add that to leaving this bit the same, x squared. Alright, and then I multiply that by the derivative of just this part here, just my second part. Now the derivative of the natural log of 2x plus 1, we determine the derivative of just the part in the brackets, which becomes 2 over 2x plus 1. And that is it. That is my answer. I stop there because we don't simplify. Alright, non-calculator part of your exam, as long as you can demonstrate how to use the product rule correctly, there's no need to do any further simplification. The next question we're going to have a look at, it's a little bit of a tricky one in the sense that it's a little bit different, I guess, to what we have sort of normally looked at. So we're going to look at, it's a little bit to do with our fundamental theorem of calculus, as well as just some manipulation of our equation to make it a bit easier to work with. So we are finding the derivative, alright, gradient function, whatever you want to call it, of my function t by root t plus the integral between t and 0 of dx on 1 take x squared. Now this part here is a bit different from what we have normally looked at, alright, with our dx being here, not at the end of our equation, but we can modify that quite easily and also simplify this a bit more so we can work out the derivative quite comfortably. So to change this up a little bit, t multiplied by root t is actually t times by t to the half. Alright, and then to make this look a bit nicer, we can actually change this to be 1 on 1 take x squared dx, and have our dx on the end like we're used to. Alright, now I'm not actually changing any of these equations, I'm just simply manipulating them so they're nice and easy to work with. Now to simplify this, alright, remember this is like t to the 1 by multiplying constants with the same base. I just add my powers, 1 plus a half becomes t to the 3 on 2, just like that. Now plus, just put this one in the same, we can't make that any easier as of yet. Alright, now we're ready to start our differentiation. So now that we've got this, my f prime of x, t rather, don't make that mistake, my f prime of t equal to, power comes out the front, 3 on 2 t, take 1 from the power to the half, plus, now I want the derivative of this. Now the way to show that I want the derivative of this part here, I want the derivative with respect to t of t to 0, 1 on 1 take x squared dx. So this part here, this is sort of my fundamental theorem. All I need to do is substitute this t in for my x, and that's it. So we end up getting 3 on 2 t to the half plus 1 on 1 take t squared. That's it. All I had to do is substitute this t into here, and we're done. That's my answer. That is my derivative. That is my gradient function. F prime t. I could change it up a little bit, I guess, if you wanted to. You could have also written this, I guess, as 3 root t on 2. Scooch that up a little bit. Plus 1 on 1 take t squared. Alright. Either of those answers would be acceptable.